Let's discuss objects falling through a fluid. That's the next topic. When an object falls through a fluid, it will experience drag forces acting upon it. When something falls through the air, it will accelerate due to its weight, as we said before, and this is due to the gravity acting on it. The best way to express this is to look at a skydiver. When they jump out of a plane, they will quickly accelerate at a rate of 9.81 metres a second squared due to the force of gravity. Now, as the body velocity increases, so do the forces acting upon it. In other words, the air resistance or drag forces, and this will start to reduce the acceleration. And there comes a point where the drag forces equal the force due to their weight, and the body will have reached its terminal velocity. So if you jump out of a plane, initially you start to accelerate, and there comes a point at a certain acceleration when you get to a point where the upward forces are no different to the downward forces, and you stop to accelerate and you've reached terminal velocity, and then they'll travel at this speed until they open their parachute. Remember earlier we said that the air resistance is dependent on the shape of the object. Well, a parachute has a very large surface area, and the air resistance will become more than the weight of the body. So the air resistance will become more than the weight of the body. This will have the impact of reducing the velocity of the body. So you might be going at a certain speed, you open your parachute, and now your velocity will actually slow you down. A point is reached again where the drag forces now are the same as the weight, and this will become the new velocity. So you jump out of a plane, you reach terminal velocity. You open your parachute off. What you've got now is, because you've got large surface area, your velocity will start to reduce. Because the drag forces are higher than what they were before, and your parachute will reach a certain velocity, and that is the terminal velocity of the parachute. That's what happens. This becomes the new terminal velocity, and this will be maintained until the parachute reaches the ground. Again, this can be shown in this graph here. You jump out of the plane, you accelerate. The rate of acceleration reduces as drag forces arise. Your terminal velocity is reached when the drag forces equal the weight forces. Your parachute opens and the drag forces increase and exceed the weight force. In other words, now you've exceeded the weight forces, and it causes a reduction in velocity. And eventually, the drag forces match the weight force again, and the new velocity comes out as the new terminal velocity. An Austrian skydiver became the first skydiver to go faster than the speed of sound, and he reached a maximum velocity of 833.9 miles an hour by jumping out of a balloon 128,100 foot up, 24 miles up above New Mexico. This guy smashed the record for the highest ever freefall, and it took him just under 10 minutes for him to descend all the way from that height, and only the last few thousand feet were negotiated by parachute. So he made sure the last few thousand feet he put over his parachute. How did he achieve such a high terminal velocity? 833 miles an hour, can you imagine that? Well, this is because at that altitude the air is so thin it offers very little resistance. Therefore, the drag forces are so low that the driving force due to weight can achieve a very high velocity. In other words, the viscosity of the air up there is very low. Now, as the air becomes denser, the drag forces increase and the terminal velocity will reduce. So what they find is, when he jumped out first of all, he'd be doing 800 miles an hour. Then as he gets denser, he'd do 700 miles an hour, 600 miles an hour. And he just kept going down like that. So what happened if you have jumped out on a planet without an atmosphere? If you jumped out of a planet without an atmosphere, well, you would accelerate according to the gravity of the planet, and this acceleration would carry on until you hit the ground, because there's no drag forces to reduce the acceleration. Yeah, that's what the air resistance does, it slows you down.